Good afternoon. This is an SPSS demonstration lesson regarding, in particular, paired sample t-tests with a review of descriptive statistics for a data set and independent samples t-tests. So we have here a distribution, a data set that you have seen before in a slightly different condition. And what it is, I'm going to clear a couple of extraneous variables here. This data set relates to a group of teacher candidates who were surveyed on their confidence in teaching math and their theory of student ability in terms of whether they believed that student ability in mathematics was fixed, that is, it couldn't be changed much by instruction, or malleable, that means that it could be changed through instruction. They were then, in this case, assigned to one of two conditions for a weekend workshop. And condition one was a fixed condition that emphasized strict pedagogical practices, particularly direct instruction, as presented in a standard exercise lesson in mathematics multiplication. In condition two, they were presented a 2-day workshop that emphasized in the same content that children's abilities in achieving the mathematics concepts and skills could be improved through instruction. And this was a random assignment. So we had, after the workshops, they were tested again on their theory of student ability. Excuse me, I'm going to get rid of one more of these. And they were also tested on a sample lesson that they administered and how many math words they used in a lesson on teaching 3rd to 4th grade students. So the first thing we're going to do is always look at the cases in our data set. So what we're going to look at are first the categorical or ordinal variables. That would be highest degree, gender, and race. We have two variables. Oh, we're not going to look at condition here, which is a categorical or nominal variable. We're going to look at that later. And this post theory has been incorrectly named in the data set, so we're not going to worry about that. I just changed that. So first, we're going to look at the ordinal or categorical variables. The highest degree is scaled as an ordinal variable because there's a progression, but the progression isn't, it's not continuous. And actually we only have 2 levels in this, and that's because some others have been edited out. So the only choices are that a participant may have already earned a BA or already earned a master's degree. So we're going to use the frequencies menu to look at our categorical or ordinal variables. So that's the highest degree earned, the gender, which is reported here as sex, and the race. And remember that the frequency tables are reported in SPSS by default. So we see here that all cases, there are 34 cases in the data set. You can just find that here because anything less than 34 would be listed as missing data. All respondents answered that question, so the regular percent and the valid percent are the same. And the majority have only thus far earned a BA. The gender as sex, 3 people did not, sorry, 1 person, 3 was coded, the value 3 was coded as missing. So 1 person did not report. 29 people reported as female, 4 people reported as male. So when there's a missing case, it's better to report the valid percent. And so you would say 88% of the sample reported as female with 1 missing case. N equals 33. And for race, everyone reported, and the majority were white, but an additional, approximately 50% were African American, Asian, or Latino. So those are our demographics categorical variables. Now we have one demographics variable, which is age, which is on a scale. And so we're going to report that as a continuous variable. And we can still use the frequencies analytic in SPSS for this. I actually prefer to use, so I reset to get rid of all those other things. And I prefer to use that, reset button there. I prefer to use frequencies because it gives me more options than simple descriptives, which is another option. It allows me to look not only for the mean, but the median, the minimum and maximum, and the standard deviation. And I like to look for all of those things, at least to start with. And so I'm going to check those off. They were under statistics and continue. And then I'm going to suppress the display frequencies default because I don't need to know, how often someone is 21. Someone in the data is 21. So what I'll get there is the statistics I requested. Everyone provided an age, n equals 34. The mean is 26. The median is lower, which means that there's a high outlier, and that's at least one, and that is the person who is 24. And if we got the distribution, we'd see a cluster of cases around 22 with 1 or 2 outliers at the upper end of the age spectrum. We're not going to do that in this case. And again, that can be found under frequencies, statistics. And if you have a continuous variable, which you can usually see from this little scale thing, unless your variable has been mislabeled, you should uncheck display frequency tables. You can also get it under descriptive statistics, descriptives. But if you choose that, you only get the mean, minimum, maximum, and standard deviation. You cannot get the median. So I like to get the median. Okay, so once we've got a sense of who is in our sample, we're going to look at some other things. And the first thing we're going to look at is that we have this condition. So we're going to look at how the design worked. And I've told you that the way the experiment, it is an experiment, was set up was that we had random assignment to one of 2 groups, one emphasizing business as usual, rather traditional mathematics instruction, and one emphasizing mathematics instruction with an emphasis on children regardless of math ability, can improve through instruction. This is supposed to be random assignment and balanced groups. So we're going to look under the condition to see if they're balanced groups. And what we did in this design is administer a pre-assessment on a theory of student ability and a post-assessment. We also administered a pre-assessment of competence. We're not going to use that in this analysis. And we also administered after treatment a post-test of theory of student ability and a post-test during a sample lesson performance of math words used. And so our hypothesis is that there are differences between the two groups on the words that they used in the sample lesson, and there are differences between the two groups on their theory of student ability after treatment, post-theory, and that in both cases, we have a directional hypothesis. We believe that participants will use more words, participants in the experimental condition, emphasizing malleability. Actually, let's say we have a non-directional hypothesis for that. In other words, we're not sure whether they will use more words or fewer words, but we want to see if they use a different number of words to a degree that is not likely due to chance. So that's a non-directional hypothesis about word use, and a directional hypothesis about differences in theory of ability after treatment. So those are both independent t-tests. We have two conditions and a dependent variable post-test use of words, post-treatment use of words, and a dependent variable post theory of student ability with two conditions, the experimental and the non-experimental treatment. So we're going to run two. We have two dependent variables, so we're going to run two separate independent t-tests. And you can, sure, I'm still sharing the right screen. And you can test those in the same, as it were, run or with a single command. But first, we want to check to make sure that we have the balanced design. We're assuming random assignment based on what the researcher told us. So we want to get the frequencies for the condition. So I'm going to reset that, and I'm going to ask for the frequencies of condition, and note that I no longer need to suppress the frequency tables. That's what I want. And by resetting, I cleared all the previous settings. So all we wanted to know here is whether everyone participated and whether it was balanced in that the two groups, whether fixed or malleable condition, were equal in number, and they were. So the next thing we're going to do before we run our statistical hypothesis test is just to look at the means and standard deviations of the continuous variables of interest. That means not the demographics, the measured variables. Confidence, which was measured pre, use of words measured post, theory measured post, and pre-theory measured pre. Sorry, these are not in the normal order. So what we're going to do is just look at the simple means overall, regardless of group. We're going to start with that. And so we're just going to look at descriptives, just the means and standard deviations. And we're going to look at them for math confidence. That was pre. Word use, that's post. Theory, that's post, and pre-theory, that's pre. One thing I want to remind you is that higher scores on theory mean more fixed. And quickly look at the options. Let's not get the minimum and the maximum. All we really want is the mean and the standard deviation. And I think that's all that's interested. We don't care about the style. So we now are going to get the output on that. So we have complete data, n equals 34 on all 4 of the variables. The word use is a count. Math confidence, theory, and pre-theory are, I believe, all scaled on a scale of 1 to 6. So 3.69 on math confidence leans slightly towards confident, and because more fixed theory of ability are higher values, post-theory and post-theory and pre-theory lean a little bit towards malleable, post-theory more than pre-theory. Again, I'm making sure that you can see my output. So we've now seen the whole group means and standard deviations, and that's something you always want to report. It doesn't particularly answer your research question, which is about between group differences, because it's whole group, but you always want to report it. Now, we also might want to look just descriptively at how the groups compare. Again, this is not going to answer any inferential questions, but it can be an interesting thing to do. So in this case, we're going to go to descriptive statistics, explore. And we have 2 dependent variables, if you remember. We want to know about use of words after treatment, and we want to know about theory of ability after a treatment. So those are post-dependent variables, things that we have measured, and we want to know if the groups differ. The factor, or what we are hypothesizing, might cause or relate to differences. So our factor is our independent variable, or our groups or levels that we think may relate to differences in the dependent variable, or in this case, 2 dependent variables. The 2 dependent variables will be taken separately, but you can put more than one of them in the box at the same time. Now, I just want to see the pictures of this. I'm not particularly interested in all the statistics because I'm going to test the statistics later. I just want to look at the pictures. So if I say I uncheck both and I leave statistics unchecked and I check plots, then I have some choices about the plots, and I only want box plots. I am not interested in the stem and leaf. So now I'm going to say the box plots. Factoring dependence together would let you compare overall word use to overall theory, and they're not on the same scale, and that wouldn't be interesting at all. Wouldn't get to what I care about. So we've asked for the plots, and the first one that pops up is word use. And what we see is that descriptively, the malleable group, that was our factor, was the condition. The malleable group are using more words at the 3rd or 4th grade level in their lesson. Around 8 is the median value. Distribution looks a little skewed. And so does this distribution, looks a little skewed. The fixed group is using, the median is 6. So it looks like the malleable group tends to be the malleable group definitely tends to be using more words. Our question is it a statistically significant non-chance difference? But descriptively, they definitely are. And descriptively, the malleable group has lower scores on theory of student ability, meaning scores that tend more to an orientation that student ability in math is malleable, while the fixed group has a theory of ability that is still generally kind of malleable, but tends more slightly towards fixed. This is an outlier variable. I think that means it's case 23. And what that means is it's more than 1.5 times the interquartile range beyond the 75th percentile. So that's designated in SPSS as a dot. So those are descriptives. It's definitely true that the median is lower and the interquartile ranges are overlapping but trend lower. For the malleable group in terms of malleability versus in terms of fixed, lower on a spectrum where high is fixed, and that the malleable group is higher in math word use than the fixed group. These are both after treatment. But what we don't know yet is whether those differences are likely due to chance, that's the null, or unlikely due to chance alone. That's the alternative hypothesis. So now we're going to go on to test that alternative hypothesis, which we would test with an independent samples t-test. We have the two groups. They don't have overlapping cases. 17 people in each group. And we're going to run two independent samples t-tests because we have two different dependent variables. We're going to test post theory of ability, which we have a one-tail test. We think that post theory of ability will be lower for the malleable group than for the group that's in the malleable treatment, than for the group that is not in the malleable treatment. And we have a post-dependent variable for word use, which we do not have a directional hypothesis for. So this is going to be found under Analyze, Compare Means, and it's the independent samples t-test. So for the independent samples t-test, you can put in more than one dependent variable at the same time. So we're going to do that. We're going to compare our two measures that we administered after the treatment. That's word use and post theory. And we're going to compare them on the grouping variable condition. And the two values that condition was coded were 1 and 2. So you have to remember what numbers those groups were coded as having so that you put in the right values here. Still sharing the right screen with you. So the only option really here is what confidence interval. We're going to test this at 0.05. Remember, one of them is one-tailed test. And we're just going to ask for the standard 95% confidence interval. And we're going to exclude, it doesn't matter, exclude cases analysis by analysis or list-wise in this case, because everyone has complete cases. But if you had different numbers of cases per dependent variable, like you'd lost some data for one independent variable, then it would be important that you do analysis by analysis, because if you exclude cases list-wise, that would mean that those people who are missing on one dependent variable would also be omitted from the test of the other dependent variable. There'd be cases when occasions when you'd want to do that, but typically you want to use all the data you have. So we're going to say that that's okay. What we report is, first of all, this is pretty much the same. It's not the same data because it's the means instead of the medians and interquartile ranges, but it's the same type of comparison as we saw with the box plots. It's for each dependent variable, those are the rows, which condition people were in. So there were 17 people in the fixed condition who were measured on word use, and the mean for that group was 5.94. There were another 17 people in the malleable group who were measured on word use, and the mean for that group was 7.9. The mean for fixed group, or the standard deviation, was 2.24. The standard deviation for the malleable group was 2.238. The mean, and you'd want to report these descriptively, but you wouldn't make inferences from just this descriptive comparison. But it looks like the malleable group is using more words, just as it looks like the malleable group tends to a more malleable theory of student ability in math. Now, before you can make any inferences, you test for the equality of variances in the independent sample t-test. And that's the assumption that the variances of the two groups are equal or equal within the bounds of chance. And in this test, this is an F test, and you look for a significance level above 0.05 for the F test, because this is a test of an assumption. So you want to retain the assumption. The assumption under the null, or the null, is the assumption. And so you do not want to reject the null. If you do not meet this assumption, if either of these values is below 0.05, then for an independent t-test, you can use this second row, equal variances not assumed, for the t-test. When the variances can be assumed, the results are very different. This row is called the Welch t, or the Welch's t. So our assumption is retained, so we can go along to the t-test. Now, this is a comparison of fixed to malleable. So it's fixed minus malleable for your mean difference. So fixed is, if it's a negative value, fixed is lower than malleable. And indeed, it is lower than malleable. The t-value is negative 0.14. So which is the same as this difference in means. Oh no, that's as this difference in means, I'm sorry. And the standard error of the difference between the two sample means is 0.769. You could hand calculate these things to test the values using the formulas you've had in class. And the significance, and remember we had a two-tailed significance alpha level, which matches the SPSS output, is 0.04. And you can see, so you reject the null hypothesis at, when your alpha is 0.05, and you can see that the confidence interval does not include the value of 0, the no confidence, the null hypothesis of no difference between the groups. So it doesn't include that, which means that under 95% of samples, the malleable group would be likely to use more math words than the fixed group. So let's look down at the theory of ability. We again meet the assumptions, so we proceed to the regular t-test. The mean difference is 0.61 approximately. So one thing you could note, if you were going to think about looking at effect size, is this version of SPSS doesn't give effect size, but the effect size is roughly the mean difference divided by the pooled standard deviation. And you can just, because these standard deviations are quite similar, you can just kind of approximate. And so that's 0.61 over somewhere between 0.75. It's about 1 standard deviation. And I'm just taking that off the top of my head. You can hand calculate that, and you can hand calculate the mean difference, the standard error of the difference, the t statistic. Use the formula. 32 is n plus n1 minus 1 plus n2 minus 1 gives you 32. And this is the 95% confidence interval. Now, the one thing I want to point out to you here is that with a significance two-tailed of 0.027, even if it were a two-tailed test, you would reject the null hypothesis. But with a one-tailed test, the two-tailed significance reported by SPSS needs to be divided by 2. And this is, I don't know if the newer versions allow you to pick a one-tailed test or a two-tailed test in the options. It would be great if it does, but if it doesn't, if you're running a one-tailed test, you need to divide whatever value is in this cell by 2. So the actual probability that the malleable group would have a more malleable theory of intelligence than the fixed group actually is associated with a 0.0135 probability value. Okay, so we're going to do one more thing, which you may have been wondering about, is what happened to the pretest? Why didn't we do anything with the pretest? Well, what we're going to do, the thing that we have covered thus far in class, is to do pre minus post. Now, for the purposes of now, what we're particularly interested in is we have an additional hypothesis that I didn't mention before, which is that through the treatment of learning to teach math with a perspective that all students, regardless of ability, can improve, that the participants in that condition will adopt a more malleable theory of ability, that there will be a change within that experimental condition. So we want to test that. And because we're now going to look at pre and post comparisons, we're going to use a dependent samples t-test. And the dependent samples t-test it simplifies to the one sample test of difference. But we're first going to run it as a dependent samples t-test, but our hypothesis is just that within the experimental malleability condition, there's a difference from pre to post, or from post to pre. So we're looking within one condition of the treatment. And so we have to do something in SPSS to say, well, we don't want to look at the whole sample anymore. We want to look at one condition. So we're going to go to a place we haven't gone before, which is data. And we're going to select cases. And this is so that we can only select those cases where the condition was the malleable one. So what you see here is that by default, the one that's already checked is all cases. And we're not going to select all cases. We're going to select only those cases where a certain condition is satisfied. And we click if there. And we are only going to select those cases that have a value for condition 2 of 2, which is the value of our malleable group. So what we've done here now is we've set up to ask SPSS to select for further analysis only those cases that are in the malleable condition, because those are the people we want to see if they changed in their theory of intelligence. They actually had the treatment, so we're interested in whether associated with that treatment, they had a change in their theory of ability. Important to note here is that the default is to filter out unselected cases. Do not choose delete unselected cases, or you will lose the cases in your data set. So you don't see anything happen here. It just puts in a report of the syntax that resulted in that selection. If you look at your data file, know where the data file is. I'm going to assume you can look at the data file. Oh, wait just a second. Yeah, you can see the data file. You'll see that with slashed lines, a whole lot of cases, it looks like this is sorted by condition, have been slashed out, which means that they won't be used in the analyses. So now we're going to take the ones that we're using in analyses, and we're going to run a dependent samples t-test or a paired samples t-test. They're called paired samples t-tests in SPSS. Either name is fine. And so what we're interested in here is comparing post-theory, okay, to pre-theory. And I'm putting them in that order because order matters with a one-tailed hypothesis. I'm interested in whether there's a increase in malleability theory from whether you have higher malleability theory post-treatment than pre-treatment. Now, little tricky logic here. If people are more malleable after treatment, they will have lower scores. So let's see what that looks like, because it's a little bit hard to explain. Okay, so you can see, first of all, the descriptives. At pre, this group had, they were about at the middle of the scale for fixed versus malleability theory of student ability in math. And that was before the treatment. After the treatment, they tended to a much lower score on this scale, and lower means more malleable. So post minus pre is going to have a negative value. And that's what you see here. The mean difference between those scores is negative 1.14. So the average difference is about negative 1 points, which means that on average, people moved lower on their theory of ability or more towards the malleable end of the spectrum. And you can see that the t-value here is negative, meaning that I think this isn't a directional hypothesis, regardless, but meaning that the t-statistic shows the same sign as the mean difference, and it has a significance lower than 0.01. So the hypothesis that there is no change, the null hypothesis that there's no change from post to 3 is rejected. There is a change from post to 3 to pre, or from pre to post. that is statistically not likely due to chance, and in particular, the people in the malleable treatment condition moved to have a theory of ability that was more malleable than it had been prior to treatment. So there's a lot more that we could do with this, including look at the effect sizes, but for the sake of time, we're not going to do that. We can either cover it in another video if you by request, or leave it to your own hand calculations, which are quite straightforward and have been covered in class.